Okay, same FRQ, new question. Find the solution y equals f of x. So back to here again, they're asking us to find this equation now with this initial condition. So that's the SASE method. Because the particular solution, this is a different example, but the particular solution y equal b of t, in our case it's y equal f of x, of a differential equation. So the particular solution of this differential equation with an initial condition is found by separate, antidifferentiate, constantate, isolate. So here we go. So we have dy over dx multiply both sides by dx. Multiply both sides by y. If I have the blue statement on my paper, I will earn the first point for separating. Now I'm supposed to take the antiderivative of both sides. The antiderivative of y, oops, there's no x there, sorry. The antiderivative of y in terms of y is going to be y squared over 2. The antiderivative of negative 2x, negative 2 is a multiplying constant. This becomes x squared over 2. We need to have plus c. If I have the green, I get the second point for finding the antiderivatives. Now I'm going to earn the third point. We'll make that one purple. For using the constant of integration, well, actually for finding the constant of integration, we find the constant, we'll go orange, by using the initial condition. So we'll actually do the orange first, then the purple. So my initial condition says when x is 1, y is negative 1. So take away the y, put in negative 1 in parentheses, squared over 2 must equal negative 2. X is a positive 1 squared. I should have divided that out, but they won't take away a point for that. So that divides out. So this is going to be 1/2 is equal to, that divides, that's negative, so that's negative 1 plus c. You add this across, you get 1/2 plus 1 is equal to c. So 3 over 2 is equal to c. Well, I'll back up a step here. Make this purple. So really, if you had this line right here in orange, they'll give you the orange point for using the constant, using the initial condition. If you go on to find the value of c correctly, you get the fourth point, which is the purple one. For the last point, we have to isolate the y. We have to get y equal. So, kind of ran out of colors here. We use the pink one there. So we go back to this equation, put in our value of c. So I have y, oops, back up. So I have y squared over 2 is equal to, these divided out, negative x squared plus 3/2. I'm trying to get y alone, so I multiply both sides by 2. There's no need to simplify anything. It's not a requirement, so I'm not going to. Take the square root of both sides. So y could equal plus or minus square root 2 times negative x squared plus 3/2. But, according to the initial condition, when I plug in 1, I am supposed to get negative 1. if I plug in a 1 here, the 1 gets squared first. So then I'll have 1 squared is 1, times negative would be negative 1, plus 3/2 would be positive 1/2, times 2 would be positive 1. Square root of 1 is 1, but I'm supposed to get a negative 1, so it has to be the negative answer. So I have to write on my paper this. Don't forget the parenthesis. So if I have this box, I will get the last of the 5 points.